This is Lab 1 Constant Velocity. My name is Alex Nguyen. So the purpose of this lab is to observe the motion of an object moving at constant speed and compare it with a computational model or the predicted um, uh, velocity, and compare the positions with the predicted positions from the model. So what we did was we recorded a video of a ping pong ball. I'm sorry, not a ping pong ball. The car rolling at a constant speed in a straight line. I imported the video into the tracker and tracked the ball's position. I mean the car's position, frame by frame, at set periods. So that's the observed position, and then I used that to create a computational model of the ball's predicted position in GlowScript by editing the starter code. And then this is GlowScript and this is the spreadsheet, and I generated this spreadsheet of the observed and predicted positions and graphed the data over time, and so here that is, and you can see that it obviously deviated a lot, the actual from the predicted. This is because due to friction being in play, and that slowed the graph down, or slowed the car down somewhat. And to find the predicted velocity, all we did was get the position vector for the actual and predicted, and we divided that to get the subtracted the change in time, and then divided divided it by the change in time by the change in distance to get a change in velocity. So we usually call that the initial velocity, and for that we got 0.388059, and that's what I plugged in to get this graph. Okay, so what would have happened if the x-axes were swapped? So the observed motion would appear as a mirror image across the x-axis. However, the gap between predicted and measured velocities would remain unchanged in magnitude. Only direction would change. And for this question, is it possible for you to say how many pushes and pulls are being added together to give zero net force in the case that you observed? The answer I got for that was we cannot determine the exact number of forces acting on the that should say car. The experiment only establishes the net force is zero at start, but many different combinations of forces, whether 2, 4, or more, can balance each other to yield a zero net force.